Hi everyone, this video is going to follow along with the Introduction to R, Rstudio, and R Markdown lesson in the course website. We also highly recommend that you read and work through this lesson for a lot of supplemental information in addition to this video. So I'm going to start by opening up Rstudio. And we're going to walk through what this IDE includes. So on the left here we have the console. This is where you directly type and execute code. For example, if you followed along with the installation instructions, say I need to install the tidyverse package. I run this in the console and it immediately executes that function. Now while that's loading, up here in the upper right we have the environment pane. This is really important once you start loading in data and creating new variables. This is where all of those will show up. And then down here in the lower right, we have a few important tabs. The Files pane is where you can essentially think of this as your file explorer on your computer, but you can use that directly in Rstudio. Plots is where whenever you make any plot or ggplot, the preview will pop up here. You can export the files with the export button here. Packages. So in the setup instructions, we give you the code to install and load in your packages, but you can also do that directly from this packages pane as well. So for example, as mentioned in the lesson, once you install a package, you only need to do that once on your computer. When you install a package, it loads all those additional functions, data, etc. to your local system. But then in order to use those functions, you need to use the library function. So for example, I just installed tidyverse. It'll print out a lot because the tidyverse is actually installing multiple packages all at once. But if I wanted to use, say, the filter function from the tidyverse packages, I would need to load that tidyverse library into my session with the library function. And as a note, you will see this message printed. This is totally fine. You will see this printed often when loading in tidyverse packages. But also, let's say I wanted to do this with Polymer Penguins. I don't have that installed yet, so I'm going to install packages Polymer Penguins. Make sure you are spelling it correctly. And now I should be able to see it here. Yep, so Polymer Penguins here. Now actually, if I just check this box, it runs the code library Polymer Penguins for me. So this is an additional utility of the Packages tab. And then we have the Help pane. This is something that I still use every day. It's how you get more information about a specific function. For example, I looked up the filter function from the dplyr package. It will give you a description of what that function does, how to use it, the different arguments. But what I find most useful is I always scroll all the way down to the examples. This is how I get direct examples of what the syntax looks like, different ways you can use it, etc. And now the fourth pane that is also important but doesn't show up by default is called the source pane. So this is where you write and save code. So in order for that to show up, you need to start writing code. So I'm going to create a new file with this plus green button, and I'm going to create an R script. Later on, we'll be working in R Markdown, but we're going to start with an R script. And this file type is when you have mostly code that is commented throughout, compared to R Markdown, where you have more written sections, and then the code is organized in individual code chunks that you can run individually, more like a notebook style. So let's say I wanted a script that I'm going to call setup. Anything that you want to comment out needs a hashtag at the beginning of that line or at the beginning of the sentence. And so as I mentioned, you only install packages once, but anytime you want to use that package in any session, you need to load it into the session with library. So you will use library every time you open a fresh Rstudio session. So let's say I wanted to save this as a script. Therefore, I don't need to manually type it out in the console every time. I can remember exactly what I did to set up that environment. That's when you want to save your code, is for reproducibility, so you can remember what you did, etc. So we'll note that I haven't saved this file yet. Whenever a file in the source pane here is red, that means it has not been saved. So I'm going to click Save. But then this brings up the question of where to save this. And so I'm going to cancel this because this is directly related to our projects. So in this class, we'll be working in R projects, and we highly recommend it for good data science practice when working with the R language. R projects are essentially a self-contained folder on your computer that will house your data, your scripts, your outputs, everything. You can put your assignments in there in organized subfolders. But it's a very effective way to make your work reproducible, and also, just for personal reasons, make it organized. So I would recommend creating an R project that you will use for this whole class. So I'm going back into Rstudio, and I like to pay a lot of attention to this upper right-hand corner here where it says Project None. If you ever see this at the beginning of your workday, you don't want to see that. We want to be working in a project at all times. So there's different ways you can create a project. You can click this button. You can either open an existing project or create a new one. You can also go to File and New Project. So I'm going to do it this way. New project. This might take a second. Let's create it from a new directory, a new project, and now we give it a name. Let's give it something like ESS 523A Fall 25. Something that you will remember. And then the second most important thing is, where are we going to save it? I often keep all of my R projects on my desktop. As you can see here, I have each folder is an individual R project that I am actively working on. We recommend that you save it somewhere that you can easily find. This is very important. And then second, we also recommend that you avoid saving them in OneDrive or any other cloud environment. It might work okay, but any programming language does not really like to work in a cloud environment. A lot of syncing issues can come up, etc. So we recommend saving it to your computer. So you can navigate to Browse. I'm going to keep it on my computer's desktop in this case. And then you can leave all the other defaults and click Create Project. I actually already created this in a demonstration, so I'm going to cancel and open that project. You can see I already have that name here. I'm going to open it. Might take a second. Okay. And so now, just to show you how this works, mine, I've already added a file. But now in your Files tab, you should see this .rproj file. This is how you know you're working in an R project. You will see in the upper right-hand corner, instead of Project None, it now says the name that you just gave that project. And to demonstrate, I'm going to close out of Rstudio and navigate. Remember, I put mine on my desktop, but navigate to wherever you just put that ESS 523A R project. Take me a second. Here's mine. And we use the words project, directory, and folder synonymously. So when you create an R project, it creates a folder in that place you specified on your computer with that same name. And the easiest way to start your Rstudio session is by navigating to that folder, that R project folder, the .rproj file, and by double-clicking that. And then that will open Rstudio in your R project. And so now I already actually saved this as setup, but say I also needed to add library Palmer penguins. Now, just to show, when you go to File, Save, it will automatically put that file in your R project folder. It assumes that you want to put any files in your project folder, which is great. You don't need to worry about navigating to where that folder is, what subdirectory, etc. I'm just going to replace that. Okay, now that we are up and running with our projects, we also recommend that you read up on what a working directory is here. It's very important to understand how the file path system works on your local computer, especially as we get into working with Git and GitHub. Local file paths become very important. Okay, so let's start coding. I'm going to go back into my, again, making sure that I'm working in my ESS 523A project. Just to demonstrate, in this lesson here, we can execute code directly. For example, R has a lot of base math calculations. We can calculate logs, we can calculate mean of values. What else do we have here? We can also print characters with print. Let's say I want to print hello class. It will print hello class. Okay, so getting back to what we were doing earlier, let's create a setup script. Again, we recommend that you read through this lesson. There's a lot of good background info on how we use packages and base R versus the tidyverse. But what we want to do is say I want to create a script that has this function in it. We've already created this function, but this is a reproducible function that we will actually build on throughout this class, that what it is doing is for a given package name, it will check if you have already installed that package. If you have not, it will install it. And then once you have it installed, it will load that library or that package using library. So I'm actually going to directly copy this package load function, which you can do from the website with this little icon here in the upper right hand corner. And I'm going to replace what I had in my setup script with my package load function. Make this a little smaller. Call this package load function. Okay, and there's different ways that we can execute an entire script. The easiest way is clicking this source button. So again, when it's red, we want to make sure we save it. Once it's saved, when we click source, it will run the entire code in that script. And it'll actually print the code it used to do that down in the console. So we just executed the code we had in our setup script. All this code did was create a function that we now have this function in our environment. We haven't used the function yet, but it exists in our environment to use later. If you ever want to look at the code for your function in the environment, you can click the script button here. And it will, I already had it open, but it will open up that function code for you to inspect. So now let's test out our package load function. Use function to set up environment. Package load. And the arguments it takes is just one argument, which is a package name. So let's do package load tidyverse. Now, if you ever want to execute just a single line of code, there's a lot of ways to do that. You can highlight it and click run. Run will execute, as it says, the current line or the selected line. What I often do is I just leave my cursor either at the beginning or end of that line. You can also highlight it again and click Command Enter, or I think Control Enter on a PC. And what that did was it sent that selected line of code down to the console to be executed. It ran package load tidyverse, and it loaded our tidyverse package for us. It didn't install it because it checked to see if we already had it installed. Since we did, it just loaded it. Now let's try and do this for more than one package. Now this is getting into vectors a bit, but I want to create a list called packages. And when we combine more than one element into a single vector, we use this lowercase c function, which stands for concatenate. And then it's important that we put package names in quotes. So I want to load tidyverse. We're going to use the 3 packages that we have in the setup instructions. Polymer penguins, again, spelling is very important, and R Markdown. And now I have this in my script. If I want to execute just this line of code, again, keep the cursor there, highlight it, whatever your preference is, and Command Enter. Now once we execute that, it now exists as a character vector in our environment. Now if we run package load on packages, it will run this function for each individual package in that list of packages. So let's Control Enter. And now we can check that it loaded all of them by looking in our packages pane. Let's check for tidyverse. Yep, it has a check mark. Polymer penguins. Yep, and R Markdown. Great. So for each of those packages, it installed it if it needed to, or it just loaded it into our environment if it was already installed. Okay, so I'm going to save this setup script because we'll be using it for the rest of the course. What we'll be doing over time is adding more and more packages to this list of packages. And at the beginning of each workflow, you'll see we run a single line of code that says source setup.r. Okay, now let's learn a bit about R Markdown. We recommend, as usual, you read the content that is in this lesson plan, but we're going to jump right into a new R Markdown document. So let's go to File, New File, or you can go to this green plus button. But instead of our script, we're going to create a new R Markdown file. It will give you this pane where you can give it title, author, etc. I'm going to call it my first R Markdown. It has this, I have this name set up in my environment somewhere, but you can add your name. This will use whatever the current date is. And then you choose your output format. So not only do you use R Markdown as a notebook style for saving and executing code, but you can also what's called render that notebook to create a nice looking report. So this is asking you what format do you want that output report to be in, HTML, PDF, or Word. Let's stick with HTML. That's probably the most easiest to work with. Okay, and so you'll see it creates this template R Markdown document. Fills in some text, has some code chunks, and talks about some of the code chunk options. Okay, so just to show you what rendering this looks like, or this file is saved, I believe, or is not. Once you hit knit, it will ask you to save. So this is, let's knit this template R Markdown by clicking the knit button. Knit also means render. We use those synonymously. If you haven't saved it yet, it'll ask you to give it a title. Again, I'll just call it my first R Markdown. Save. And then I'll open, oh, it went really fast, but it'll open this render tab, which is essentially, it's executing this R Markdown document in the background and then creating this output document. And so this is the report that is rendered based on the code in this R Markdown document. And now we'll also see, if I refresh this, not only is my R Markdown, which is a .rmd file, but now it has the .html output report that it created. And so we'll get into this more later, and there's a lot more details on the lesson plan about how you can set code chunk arguments that dictate whether you want the code to show in the report, whether you want the output to show in the report, whether you just want the output to show in the report, etc. by setting echo equals false, include equals false or true, things like that. But we're going to focus on using R Markdown for code execution. So I'm actually going to delete all the template text. I'm going to keep my title, author, date. You'll notice that this is some new syntax here where we have these 3 dash lines before and after. This section between those dashes is what's called a YAML header. This is where you set kind of the global options for your rendered report, like not just title and author and date, but also output format, and there's a lot of other arguments you can put in this YAML header. Again, this might not be relevant until further down the road. This chunk here, we notice now instead there's these 3 dashes. Anything between these 3 dashes is code. So if I start typing text here, unlike an R script, any text is assumed to be written text. Whereas here we needed to put a hashtag in front of that. Anything in the main document of an R Markdown is assumed to be text. And then we put code in what's called code chunks. So let's take that one out too. There's a lot of different ways you can create a code chunk. First, we're going to start with setup. So the keyboard shortcut, I believe, is Command-Option-I on a Mac. I think it's Control-Alt-I on a PC. Or you can also go to this +C button, which stands for code, and click R. Notice that you can actually execute other languages in RStudio, but we will be sticking with R for this course. And that does the same thing. It creates a code chunk. I'm going to delete that one. And so what we always want the first code chunk of our R Markdown document to be is setting up our environment. And to do that, instead of running library tidyverse, library Polymer Penguins, etc., we've already written that once in this setup script. And so now all we have to do is execute this setup script, which we can do with the source function. And we're going to put file path in quotes. We always put file paths in quotes. I'm going to find, you can also tab autocomplete. If I start typing set, it'll autocomplete setup.r. And so this is related to working directory, and that note that since the setup script is in my R project file, I don't need to put any file path ahead of this. I just need to put setup.r, and it knows that it's in my R project folder. And now to execute a code chunk, we click this green arrow. And now that sent that line of code down to the console here. And we had already loaded all of our libraries, so it doesn't print anything else. But if this was a fresh session, it likely would print all that text it does with tidyverse and Polymer Penguins, etc. So I'm going to save this again. It's good practice. Okay, and now we have our environment set up. We have a new R Markdown document, and we have loaded and executed our setup script. So let's start coding. So for the rest of this first lesson, we recommend that you just work through this explore section, read up on all of the text. This works through loading in the Penguins dataset that we get with the Polymer Penguins package, how you can explore data, different data types, how you work with different data types, indexing. Pay a lot of attention to indexing. It's one of the most important skills that we use when working with data. And indexing varies based on the data type you are working with. And then at the bottom here, we have exercises. These are not required, but good to work through if you want.